Greetings. Yes, we're going to talk about deductive reasoning. It's quite elementary. We're going to first talk about the law of detachment. So the law of detachment says that, say we have a true conditional statement, and then we find out some information that matches the truth of the hypothesis. Then we can conclude that the conclusion is true. It seems sort of obvious, and it really is. It's like this. Here's a conditional. If it's raining, then the ground is wet. And that's true. If it's raining, the ground's going to be wet. Okay, so there's my conditional that's true. Now let's say I have a statement that says my hypothesis is true. Hey, it's raining outside my house right now. Well, now I can conclude that the ground is going to be wet outside my house right now. And that is the quite obvious law of detachment. You might even say it's elementary, my dear Watson. Awkward pause. Alright, let's use the law of detachment. If a student gets an A on a final exam, there's my hypothesis, then the student will pass the course. Conclusion. Random statement. Felicia got an A on her history final exam. That matches the hypothesis, therefore I can make a conclusion. My hypothesis was this, my conclusion is this. My random statement matches my hypothesis, so I can use my conditional statement to make a conclusion about this specific situation. Since Felicia got an A on her history final exam, I must conclude that she will pass her history course. Yay, Felicia. Elementary! B. If a ray divides an angle into two congruent angles, then the ray is an angle bisector. Also, we happen to have this situation. Ray RS divides angle ARB, so that angle ARS is congruent to angle SRB. Let's draw a picture. I like to draw pictures. Alright, here's the big angle, angle ARB. ARB. And we have ray S that divides it into two congruent angles. Ray RS divides it so that angle ARS is congruent to angle SRB. Okay. So if a ray divides an angle into two congruent angles, then the ray is an angle bisector. Here we have a specific instance of a ray dividing an angle into two congruent angles. Therefore, we can say that ray RS is an angle bisector. And it's bisecting angle ARB. ARB! If two angles are adjacent, that's my hypothesis. My hypothesis is two angles are adjacent. Then they share a common vertex. That's my conclusion. Here's my specific situation. Angle 1 and angle 2 share a common vertex. Now, can we conclude anything from that? This, our specific situation, is matching the conclusion. So does the conclusion always mean that the hypothesis is true? No, it doesn't. The converse of a statement is not always true. And in fact, I can think of a situation. Here, let's call this angle 1. And we'll call this the vertex V. And then here's angle 2. They share a common vertex, but they don't share a side, so they can't be adjacent angles. So what we get from this is, if we get our specific situation, it has to match the hypothesis in order to use the law of detachment. If it's matching the conclusion, we can't make a conclusion. And that's what all this says. The second statement doesn't match the hypothesis of the given conditional, so we can't use the law of detachment. So, what can we conclude down here? Go ahead and pause the video and see if you can figure out what you can or can't conclude about A and B. So in A, here's my conditional. If there is lightning, then it is not safe to be out in the open. Here's my second statement, my specific situation. Marla sees lightning from the soccer field. That does match my hypothesis, so I can use the law of detachment to say that it is not safe to be out on the soccer field or out on the football pitch if you're elementary. Alright, how about B? If a figure is a square, then its sides have equal length. And then our specific figure ABCD has sides of equal length. That doesn't match the hypothesis, so we can't make a conclusion. So we're going to say no conclusion. And we can talk about why. How about a figure? We can give a counterexample that says why we can't have a conclusion from that. Here is a four-sided figure that has sides of equal length. It's called a rhombus. It's not a square. It's like a parallelogram with sides of equal length. Not a square. Totally elementary. And you may have seen a split second of your secret word of the day, which is gobbledygook. Gobbledygook. How about the law of syllogism? That sounds pretty cool, right? Sounds cooler than the law of detachment. Who likes detachment? Not me. I like syllogism. Okay, so the law of syllogism says if P implies Q is true and Q implies R is true, then P implies R must also be true. So if P then Q is true, and if Q then R is true, then we can go from the beginning straight to the end. Then if P, then R. Sometimes speaking in logic just sounds weird, huh? So here's an example. If it's July, then you are on summer vacation. So there's your if P, then Q. If you are on summer vacation, then you work at a smoothie shop. That's your if Q, then R. So, by the law of syllogism, you can conclude that if it is July, then you work at a smoothie shop. Cool, huh? If you remember from algebra, you might remember there's a property of numbers, like if A equals B and B equals C, then A equals C, and that was called the transitive property. And so the law of syllogism is like the logic version of the transitive property. So, cool, huh? Alright, check out A. If a figure is a square, then the figure is a rectangle. If a figure is a rectangle, then the figure hath four sides. So, we can use the law of syllogism because this is true. If a figure is a square, then it's a rectangle. Because a rectangle just means it has four right angles, and a square always has four right angles. And if a figure is a rectangle, then it has four sides. That's true, because a rectangle is a four-sided figure that has all right angles. So what can the law of syllogism do for us? We can take if P then Q, and then if Q then R, and we can make it go right there. And we can say if a figure is a square, then the figure has four sides. The power of syllogism. How about this one? If you do gymnastics, then you are flexible. If you do ballet, then you are flexible. Well, let's see. That doesn't go. P implies Q. And then we got a Q down here and an R. P implies Q, R implies Q. Can we go straight from P to R? If you do gymnastics, then you do ballet? No. Those are both things that flexible people would probably be good at. But just because you do gymnastics and you're flexible, that doesn't mean you also do ballet and are also flexible. So you notice that they have the same conclusion. We're not going from this conclusion back to this hypothesis. So we cannot use the law of syllogism. We cannot make a conclusion here, except that there are lots of flexible people doing ballet and gymnastics. Alright, so take a look at number 2 here. See what you can conclude from A and B. Alright, A, if a whole number ends in 0, then it is divisible by 10. If a whole number is divisible by 10, then it is divisible by 5. So we got the right format here. If P, then Q. If Q, then R. We just have to determine if they're true. So if a whole number ends in 0, then it's divisible by 10. 10 goes into it. So is that true? So let's think. We got 10, we got 20, 300, 0. Are all these divisible by 10? 300 divided by 10 is 30. 10 divided by 10 is 1. 20 divided by 10 is 2. 0 divided by 10 is 0. So none of those had remainders. So yeah, if a whole number ends in 0, then it's divisible by 10. That's true. How about this? If a whole number is divisible by 10, then it is divisible by 5. Well, if 10 is going to go into it, 5 is also going to go into it just twice as many times, because 5 goes into 10 twice. So that's also true. So the conclusion we can make, that means, hey, we're allowed to use the law of syllogism. We got P implies Q, true. Q implies R, true. So now we can say P implies R. So our conclusion for A is, if a whole number ends in 0, then it is divisible by 5. How about B? If ray AB and ray AD are opposite rays, then the two rays form a straight angle. That's true. So P implies Q is true there. If two rays are opposite rays, then the two rays form a straight angle. Well, this one is Q again, so this one would be just kind of like a different version of P, but we don't have the right format. We don't have P implies Q and then Q implies R, so we cannot make a conclusion because we cannot use the law of syllogism. Alright, now you can use the laws of syllogism and detachment together. So, if you live in Accra, which is this city right here, then you live in Ghana, which is this country right here. This country on the continent of Africa. So here's Ghana, right here in Africa, right next to the Ivory Coast. Alright, if you live in Ghana, then you live in Africa. Okay, that seems to make sense. So if I live in Accra, then I live in Ghana. That's true. If I live in Ghana, then I live in Africa. Well, that's also true. And then here's another statement. Aisa lives in Accra. So here's our if P, then Q, then if you live in Ghana, you live in Africa, so there's if Q, then R. So we can use the first two statements and use the law of syllogism to say that if you live in Accra, so that's if P, then you live in Africa. And we can also use the law of detachment because Alyssa lives in Accra matches our conditional hypothesis. So we can use the law of detachment to say that this conclusion applies to this statement. So we can say that Aisa, sorry Aisa, I said your name wrong. Aisa lives in Africa. I hope you're not mad at me, Aisa. So what can we conclude from that? Okay, so if a river is more than 4,000 miles long, then it is longer than the Amazon. If a river is longer than the Amazon, then it is the longest river in the world. The Nile is 4,132 miles long. So, we can use the law of syllogism first. So if a river is more than 5,000 miles long, there's if P, then it is longer than the Amazon. There's Q. If it's longer than the Amazon, it's Q again, then it's the longest river in the world. So then the law of syllogism, we can do P, if P, then R. So we can say if a river is more than 4,000 miles long, then it is the longest river in the world. And then we have this statement, the Nile is 4,132 miles long. So now we can say, using the law of detachment, that the Nile is the longest river in the world. So we use the law of syllogism and then the law of detachment. So what about B? In problem 3, does it matter whether you use the law of syllogism or the law of detachment first? Let's see. If we had used the law of detachment first, then we would have said that we would have used this first statement here to say that, well, the Nile is more than 4,000 miles long, so the Nile is longer than the Amazon. And that would be using the law of detachment. So then, to use this statement, if a river is longer than the Amazon, then it's the longest river in the world, we would have to use the law of detachment again and say, well, the Nile is longer than the Amazon, so the Nile is the longest river in the world. So it does make a difference, because if we use the law of detachment first, then we don't use the law of syllogism. We just use the law of detachment twice. We end up with the same conclusion, but we get there a different way. Alright, there's your lesson, Sherlock. I hope you enjoyed it. Now go ahead and practice your deductive skills on practice 2.4 and formal write-up 2.4. Bye-bye.